Welcome to Sanjay Gowda IIT and Medical Academy. My name is Uday Shankar. Today I am going to discuss the motion on a straight line in kinematics topic. See, the equations of motion when a body is moving along a straight line with uniform acceleration. This is important, uniform acceleration. Here, we have to discuss all equations of body motion when it has uniform acceleration. Uniform acceleration. Now, let us consider a body started from A with initial velocity u. With initial velocity u. And it is accelerated. Now with acceleration a, this acceleration is constant. It after traveling distance s, it comes to point B and here there is velocity v. This motion is completed in t seconds. So body is moving from A to B, started with initial velocity u, with acceleration a, after traveling s distance, because distance and displacement are same, in t seconds, it reaches the point B with velocity v. Now, acceleration, we know that acceleration is equal to rate of change in the velocity. Change in the velocity. Change means v minus u. Rate means by time. Rate of change in the velocity, acceleration. Kinematics starts with this definition. Acceleration A is equal to v minus u by t. Rate of change in the velocity. Rate means by time. Change in the velocity v minus u. From this, at equal to v minus u. V equal to u plus at. This is first equation. V equal to u plus at. Now, displacement s. Displacement s is average velocity into t. Average velocity into t. Average velocity. Here average velocity means u plus v by 2 into t. This is very important formula. This is possible only when body is moving with uniform acceleration. Average velocity u plus v by 2 into t. Now, u plus v value is already we have u plus at by 2 into t. I am substituting v value here, u plus at by 2 into t. Then I got 2u plus at by 2 into t. So, s is equal to ut plus of at square. S is equal to ut plus of at square. You know this one in your lower classes. Again, we know that s is equal to u plus v by 2 into t. Average velocity into t. Average velocity into 2. Average velocity into t. What is? You know that u value. We know one formula, v is equal to, this is basic formula, u plus at. Now I am replacing u. U is equal to v minus at. So instead of u, I am writing v minus at plus v by 2 into t. Then you are getting that s is equal to here 2v by 2. V t minus half at square, of AT square. Okay. Now, this is the second formula. This is third formula. Here initial velocity and acceleration are given. You have to use this one. Here we have no final velocity. Here final velocity, acceleration is given. We have to use this formula. Now, again I am taking the basic formula. S is equal to average velocity into average velocity into t. Average velocity means u plus v by 2 into t. But v equal to u plus at. So, v minus u by a is equal to t. Then we have to write S is equal to v plus u by 2 into time is v minus u by a time instead of time. This time I am substituting this value here. I got v square minus u square by 2a is S, or v square minus u square is equal to 2as. This is the fourth equation. When this formula is useful, here time term is not there. Time is replaced. Here initial velocity is replaced. Here final velocity is replaced. So, based on the situation, if initial velocity, acceleration, time are given, you have to write displacement is equal to. If final velocity and acceleration is given, displacement equal to. Time is given. In these two cases, time is given. But here final velocity, initial velocity, acceleration, displacement are given. You have to use this formula. Now, a body starts with velocity u. It starts with velocity u. And moving with uniform acceleration. I am discussing only the motion with uniform acceleration. In n seconds, displacement of the body is Sn. In n seconds. We know that is, I am taking that is S1 I am taking, usually Sn is S1, that is Sn is equal to ut. Instead of t, here t is in n. That Sn is S1 I am writing, S1 is equal to ut, t place in the t, I am substituting n, un plus of a n square, at square. In n minus 1 second, suppose in n minus 1 seconds body comes here. So, in n minus 1 seconds displacement of the body, I am taking that this is S2. Then H2 is equal to ut. Instead of t, I am writing n minus 1 plus of a n minus 1 whole square. Here, I calculated this displacement in n seconds, this displacement in n minus 1 seconds. Then I have to find out in nth second, 0 to 1, first second, 1 to 2, second, 2 to 3, third second. This way, n minus 1 to nth second. So, this nth second, only in this second, how much distance travelled? In order to find out that one, we have to subtract that S1 minus S2. S1 minus S2. Then this is S1, this is S2. S1 minus S2. So distance travelled by the body in nth second. That is S1 minus S2. S1 is already we wrote Un plus of a n square. S2 is Un minus 1 plus of a n minus 1 whole square. I am expanding this one Un plus of a n square minus Un plus u minus of a minus half a n square plus 1 minus 2n. Then Un plus half a n square minus Un plus u minus half a n square minus half a plus an. Then I got this Un minus Un will cancel. I am writing that half an square minus half an square cancel. Here I have u. I wrote u. Here I have minus half a. I wrote that. Here an. Then in the nth second, distance travelled is u plus a into n minus half. Distance travelled is u plus a into n minus half. So, the basic equations are v equal to u plus at. Next equation s is equal to ut plus of at square. Next one more equation vt minus of at square. Next equation is v square minus u square is equal to 2as. Sn is equal to u plus a into n minus half. But these are all derived from displacement is u plus v by 2 into t. Average velocity. This formula is applicable only, all these formula applicable only if body is moving with uniform acceleration. Uniform acceleration. Suppose acceleration 0, this is 0 ut. Displacement is velocity into time. Here also. Okay. So, this is the formulae. These are the equations of motion. We are frequently using all these formulae in physics. Without these formulae, you can't do any problem anywhere in the physics. Now, I am giving one problem. A body is moving with uniform acceleration, travels a distance Sn is 0.4 n plus 9.8 meters, 9.8 meters in nth second. Nth second. Find the initial velocity, acceleration, velocity after 4 seconds from starting, displacement in 3 seconds. These are the things we have to find out. For that, we have to know that this is given Sn is equal to 0.4 n plus 9.8. But actual formula is Sn is equal to u plus a into n minus half. Now, you have to convert this one into this form. Convert this one into this form. How? First of all, Sn is equal to I am taking 9.8 plus here 0.4 n is there. Then what I have to write? 0.4 common n. Okay. This is over. This is over. But I am writing this minus 1 by 2. Actually, this term is not there. Extra term, what I wrote? 0.4 minus 1 by 2. That term we have to add 0.4 into 1 by 2. Then this 0.4 n minus 0.2 plus 0.2. These two will cancel. Then you will get same as it is, this form. Now, I am writing this one is 9.8 plus 0.4 by 2. This is 0.2. So, 9.8 plus 0.2. What I am getting now? 10 plus 0.4 n minus half. Just if you expand this one, you will get this one. 10 minus 0.2, 9.8 plus 0.4 into n. You will get that. Now compare this equation. Here, compare this equation with this equation. Then what I am getting? U value is 10. U value is 10. U value is 10. A value is 0.4. So, we know these two, you can calculate anything. U value is 10, A value is 0.4. Then, what they are asking? Initial velocity. Already initial velocity we calculated. That is, initial velocity is 10. U is 10. What is the acceleration? Already calculated acceleration is 0.4. Velocity after 4 seconds from starting. Velocity after 4 seconds. Already we wrote that U value. This is U value. This is A value. Velocity. I am writing that V is equal to U plus AT formula. U is 10. A is 0.4 into T4. So, 10 plus 1.6. V value is 11.6 meters per second. Next question, we have to find out the displacement after 3 seconds. Displacement after 3 seconds. So, I am using this formula S is equal to ut plus half AT square. U is already 10, time is after 3 seconds I have to find out. So, time is 3 plus half A is 0.4 into 3 square. So, 30 plus 0.2 into 9, 30 plus 1.8, 31.8 meters. Okay. So, just I am writing the formula that what is given that I am converting into this formula. Okay. From this, I calculated U, I calculated the A. Then everything can be calculated what they are asking. Now, they are giving that for a body traveling with uniform acceleration. Its final velocity V is equal to this one, where here where x is the distance travelled by the body in a straight line. Find its acceleration. This is the question. This is V equal to root 180 minus 7x. Uniform acceleration. It is given with uniform acceleration. We know this is V displacement. So, V displacement are given, we know one formula, V square minus U square is equal to 2AS. But they gave that V is equal to root 180 minus 7x. I am squaring this one, V square is equal to 180 minus 7x. V square minus 180, I am taking 180 this side, that is minus 7x. V square minus root of 180 whole square. V square minus root of 180 whole square is equal to 2. A is minus 3.5 into Ax. Because I am writing that, I want to get this formula in this formula, V square, I have V square, okay. U square, I have U square, okay. 2 should be required. That's why I split this 7x, 7 as 2 into minus 3.5, minus 7 as 2 into minus 3.5 into x. X is S. Then I got acceleration is minus 3.5 meters per second square. Minus indicate that is retardation, deceleration. Velocity is gradually decreasing. Okay, this is the negative acceleration means retardation. Same model, I am giving one more problem. The displacement x of a particle at the instant when its velocity v is given as this one. V is equal to root 3x plus 6. Find the initial velocity and acceleration. So, V is equal to root 3x plus 6. Squaring, V square is equal to 6 plus 3x. Take 6 to that side, V square minus root 6 whole square. I am writing 6 as minus root 6 whole square is 3x. So, V square minus root 6 whole square is equal to, I have to split this one into 2. A is 1.5, 2 into 1.5, 3 into x. From this is U, initial velocity, units. Here they are not giving that units. Suppose either meters per second is given, then we can write meters per second, but we don't know that units, that's why I am writing. A is 1.5 units. If it is given meters per second, here 1.5 meters per second square you will get. So, in this way, we can write the formula. We are converting the given formula, the given equation into this formula. Then we are finding. Once you know the U and A, you can calculate anything. Suppose velocity after t seconds, they are asking equal to U plus AT. Now, a particle starts from rest. So, U0 with moving with uniform acceleration. It travels a distance x in first 2 seconds and a distance y in the next 2 seconds in a straight line. Then, what is the relation between y and x? So, it is started at this point U0, started from rest means U0. In 2 seconds, it travels distance s is equal to x. Next 2 seconds, it travels distance s is equal to y. I am writing that s is equal to ut plus of at square. Yes, here I know the velocity, initial velocity 0. S is x plus half a, t is 2 square. I got x is equal to 2a because 4 by 2, this is 2a. This is equation number 1. But I don't know here the velocity. I know initial velocity 0. So for that, I am taking the total motion. The total motion is here u is equal to 0. Total time is 4 seconds. Total displacement is x plus y. Why I am using this one? Because I don't know here velocity. So then total displacement is x plus y. I am again applying s is equal to ut plus half a t square. So total is x plus y is equal to, here I know velocity 0, but total time is 4 seconds plus half a into 4 square. So I got x plus y is equal to 8a. This is equation number 2. From this, I am writing that x plus y is equal to 8a, x is equal to 2a. So x plus this equation by this equation I am writing. X plus y by x is equal to 8a by 2a. So a will cancel. So x plus y is equal to 4x. Y is equal to 4x minus x. Y is equal to 4x minus x. Then y is equal to 3x. So your answer is y equal to 3x. So you have one doubt that you find out this velocity at this point, and also you can use this formula again. V equal to, here V is u, s is equal to half a t square. Instead of doing that, I am taking here velocity I know, then total time and total displacement I am taking. Now, a body covers 200 centimeters in first 2 seconds and 220 centimeters in the next 4 seconds under constant acceleration. Find the velocity of the body after 7 seconds from start. Here, they are not saying that it is started from rest. So, again, initial velocity, I have u. So, in t seconds, again I am using s is equal to ut plus half a t square. First, I am considering this one. Here, 200 centimeters, u into 2 plus half a into 2 square. Then what you are getting that? 200, this is equal to, this implies 200 is equal to 2u plus 4 by 2 means 2a. Then it is divided with 2. Then you will get 100 is equal to u plus a. I got the equation. This is I am taking first equation. This is the first equation. Next, I don't know here velocity. That's why I know here velocity. So, instead of this distance, I am taking total distance and total time. Then again, total distance 420, s is equal to, in this formula 420, s is equal to 420. Total time is 6 seconds plus half a into 6 square. So, 420 is equal to 6u plus 18a. Divided with 6, 70 equal to u plus 3a. This is equation number 2. Okay. So you have to solve this equation. So we have, what we have? 100 is equal to u plus a, one equation. 70 equal to u plus 3a. To find out the a, I am subtracting these two. 100 minus 70, 30 is equal to u minus u0 minus 2a. So a is equal to, I have minus 15 meters per second square. I got it. See, either centimeters, sorry. Centimeters, because this is in centimeters. So this is centimeters. So I am writing minus 15 centimeters per second square. Once you know a, you can find out the u value. You can substitute any value here. 100, I am taking this first equation. 100 is equal to u plus a is minus 15. Then u is equal to what you are getting? 115 centimeters per second. So, then we can, once you know this u and a, after 7 seconds velocity you have to find out. Velocity is equal to u plus at. I have v value is equal to, u value is 115 plus a value is minus 15 into t7. So that is equal to v value 115 plus minus 15 into time is 7. So 115 minus 15 sevens are 105. You will get that 10 centimeters per second. That is the velocity. Velocity is 10 centimeters per second. In this way, here it is started from rest is not given. That is the difference between previous problem and this problem. Now, a body is traveling with uniform acceleration. Uniform acceleration means we have to apply the formula. They are giving that. Crosses the point A and B with velocities 20 meters per second and 30 meters per second. Then the speed of the body at the midpoint of A and B is midpoint of A and B at midpoint. Here at A, 20 meters per second. At B, 30 meters per second. Midpoint means this is S by 2, this is S by 2. Here I want to find out the velocity V. For that, V, U, S. Time is not there. So that's why I am using this. V square minus U square is equal to 2AS. So V square, here velocity is V square minus U square 20 square is equal to 2A. S value is S by 2. This is equation number 1. Now, from this one to this one, 30 square minus V square is equal to 2A S by 2. Then, dividing this by this किया तो आप V square minus 20 square by 30 square minus V square, this one will cancel, you will get the 1. Then, V square minus 20 square is equal to 30 square minus V square. So, 2V square is 900 plus 400. V square is 1300 by 2. So, V is equal to root 650. Its value if you calculate 25.5 meters per second. 25.5 meters, nearly approximately. 25.5 meters per second. I am using here V square minus U square is equal to 2AS formula. Previously, I used the formula S is equal to ut plus half at square. Before that, I used Sn is equal to u plus a into n minus half. I am doing all the applications of that formula given, equations of motion. Now, if a body loses half of its velocity after penetrating 3 centimeters in a wooden block, suppose this is a wooden block, a bullet is fired here, actually with velocity u. After traveling 3 centimeters, its velocity is equal to u by 2. Here, if you take v by 2. And how much will it penetrate more before coming to rest? This distance is what? How much more it will penetrate before coming to rest? Finally, its velocity is 0. It will go until its velocity is 0. Then I am using this formula, v square minus u square equal to 2as. First, v by 2 whole square minus v square is equal to 2a into 3 centimeters. So, v square by 4 minus 4, either here v square, I am writing 4v square by 4 for a simple calculation, is equal to 6a. That means, so minus 3v square is equal to 24a. This is first equation. Now, 0 square. Next, I am applying for this one here 0. Here v by 2. This distance is x. So, 0 square minus v by 2 whole square is equal to 2ax. From this, I got that minus v square by 4 is equal to 2ax. This is second equation. Dividing the 2. So, you can write, simplification is, you can write, see, this by this, if you write, this by this, if you write, minus 3v square by minus v square by 4, 4 comes to the numerator, is equal to 24a by 2ax. Then v square cancel. So, minus becomes plus. 12 is equal to a will cancel. You will get 12 is equal to 12 by x. So, x is equal to 1 centimeter. Just simplification. Here you have to write, this is v, this is v by 2. I am applying v square minus u square is equal to as here. Again, I am applying 0 and v by 2. I am again applying that formula and division. Suppose a particle is moving with uniform acceleration along a straight line ABC. Its velocities at A and B are 6 meters per second. At A 6 meters per second, B 9 meters per second. If AB is to BC is 5:16, then we can write this one, S1 is 5x, S2 is 16x. Then its velocity at C. I want to find out the velocity at C. See, here we have S and velocities are there, time is not there. That's why I am using the formula v square minus u square is equal to 2as. First, this is 9 square minus 6 square is 2a into 5x. That is 81 minus 36 is equal to 10ax. So, ax I got 45 by 10. This is equation number 1. Again, I am applying formula for this case. So, y square minus 9 square is equal to 2a into 16x. So, what you are getting now? Y square is 32ax plus 81. Y square is 32ax plus 81. So, y square is 32 into ax. From 1 we can write ax is 45 by 10 plus 81. Then if you simplify this one, y square is what we are getting, that this value is 225 you will get. 225 you will get. Then y value is root of 225, that is 15 meters per second. So, here you are getting 15 meters per second. Just I am using the formula v square minus u square is equal to 2as. See, a police party is moving in a jeep at constant speed v. This is a police party moving in a jeep at constant speed. Police वाला constant speed से जाता है. They saw a thief at a distance x on a motorcycle which is at rest. The moment the police saw, the thief started at constant acceleration alpha. Once thief, what he will do? Definitely after seeing the police, he will go with what maximum speed he can move. That means he will go with some acceleration. Then, which of the following relation is true if police is able to catch the thief? In order to catch this thief, what is the required equation? See, to catch the thief, this police should travel the distance. Already initially there is some separation x, plus in that time thief will travel distance. That distance is equal to ut plus of at square. Here he started from rest, thief is at rest. So, s is equal to, if you write ut plus of at square, u0, a is alpha. So, that distance is of alpha t square. So, he has to catch this thief. Already thief in t seconds comes to this point. Then this policeman should travel this x distance plus this d distance. Then x plus of at square. Total distance is what? Policeman should cover x plus of at square. Of a means alpha t square. But the policeman travel with uniform speed. So, distance travelled by the policeman is equal to distance of the thief after t seconds. So, distance of travelled by the policeman travelling with uniform speed. So, acceleration 0, only Vt, acceleration of at square, a0 for policeman. But for thief, Distance travel, this one is equal to distance of the thief in t seconds is equal to already this separation x plus this half alpha t square. So, x plus half alpha t square is equal to Vt. We are getting one quadratic equation of alpha t square minus Vt plus x is equal to 0. Then this t quadratic equation minus b means minus of minus plus v plus or minus b square. B square means v square minus 2as. 4a, sorry. V square minus, actual formula is what? Minus b plus or minus root of b square minus 4ac by 2a we have to write. So, minus b means plus v plus or minus b square means minus v whole square minus 4ac. 4 into a value is half alpha, c value is x. So, that is equal to 2 alpha x. But this time is real. So, this should be real. To get this real value under the root v square minus 2 alpha x, this term should be greater than or equal to 0. Inside the square root, if you get the minus value, you cannot get the real values. Imaginary values you will get, but time is real. So, v square minus 2 alpha x should be greater than or equal to 0. So, v square should be greater than or equal to 2 alpha x. So, v square should be greater than or equal to. So, definitely here greater than, definitely he will catch. Definitely he will catch. V square should be greater than 2 alpha x. If this condition is satisfied, then only he can catch that one. Next, a car accelerates from rest at constant rate of 2 meters per second for some time. Then it retards at a constant rate of 4 meters per second square and comes to rest. If the total time for which it remains in motion is 3 seconds, what is the total distance travelled? First, car starts from rest. Car starts from rest, u0, at a constant rate 2 meters per second square. Let us take this time is t1. Then here velocity is v. Here velocity is v. Then it retards. With constant, retards means minus 4 meters per second square. Now this time t2. This time is t2. This time is t2. That t2 is equal to total time 3 seconds. Total time 3 seconds minus t1. This t2 is equal to total time 3 seconds minus t1. Here we have retardation. Total time is 3 seconds. So, here I am calculating V. V is equal to U plus A1 T1. So, U0, A1 is 2 T1. So, I got V is equal to 2 T1. This is the first equation. Next, I am writing this. I am writing this one. V is equal to, again, U plus A2 T2. Here V is 0. Initially here V minus 4 into 3 minus T1. So, from this equation, I got V is equal to 4, 3 minus T1. This is equation number 2. The first equation, I got 2T1. Here, I got 4, 3 minus T1. Here, what I did? Here, I am applying the formula again. V is equal to U plus AT. Here, V is 0. U is V minus 4 into 3 minus T1. So, V is equal to 4 into 3 minus T1. So, I am equating these two because both are V na. I am equating these two. 2T1 is equal to 4, 3 minus T1. So, T1 is equal to here 2 times cancel 6 minus 2T1. So, T1 plus 2T1 is equal to 6. So, 3T1 is 6. T1 is equal to 2 seconds I got. T1 is 2 seconds I got. So, then what we can write now? T1 is equal to 2 seconds I got. Then first S1 is equal to UT1 plus half A1 T1 square. S1 is initially U0 of A is 2, T1 is 2 seconds. Then first distance is 4 meters. Now, S2 is equal to VT2 plus of A2 T2 square. Here V is this velocity. Then we got that V is equal to, before that we got that V is equal to 4, 3 minus T1. So, V value is equal to 4 into 3 minus T1. So, 3 minus T1 is 2. So, V is equal to 4. Then, I am writing that V value is 4 into T2 is 3 minus T1 plus of A is here retardation minus 4. T2 square, 3 minus 2 whole square. So, then I simplified this one, 4 into 1 minus 2 into 1. Then S2 is equal to, I got the 2 meters. So, total distance is S is equal to S1 plus S2, that is 4 plus 2, that is 6 meters. So, here, whenever this is given, first acceleration, next retardation. Even retardation is given, you take the magnitude. There is a short trick. It is started from rest. I can write short trick, shortcut. Shortcut has no logic. You have to remember that one only. So, S is equal to U into T plus of A into T square. So, instead of U, you have to write 0 into T plus instead of A, you have to write A1, A2 by A1 plus A2. Only magnitudes you have to take. Don't take negative acceleration into total time. Directly, you will get that S is, this is 0 plus of A1, A2. A1 is first, A1 is 2, A2 is, what is the A2 we got that? 4. 4 by 2 plus 4 into time is total time you have to take. then you will get 4 by, this is equal to 1 by 2 into 8, 1 by 2 into 8 by 6 into 9, that is equal to 6 meters. Simply in one step you will get. Similarly, at this point, up to this point is accelerating. So, velocity here maximum. You can find out that maximum velocity with short, simple trick. You have to write V is equal to U plus AT. U value is equal to 0. Instead of A, you have to write A1, A2. A1, A2 by A1 plus A2 into T. A1, A2 by A1 plus A2 into T. Directly you can write that one. So, you will get directly substitute the values. T is total time. So, this formula is applicable. These shortcut tricks are applicable only if it is started from rest, and first acceleration, next immediately retardation. Then only we can write that. Otherwise, you have to follow that total problem. Thank you.